Hi, my name is Jerry Carlson, and I'm the team leader of the Buggy Technology Development Surge. This project was conceived as an inter-organization think tank. We'd have members, representatives from several different teams in the sport of buggy at Carnegie Mellon come together and work on projects, develop ideas, and different techniques that would improve the safety of the sport, the quality of the buggies, and just benefit the community as a whole. The sport of buggy is kind of notorious for its secrecy, the harsh competition between teams, kind of general poor sportsmanship, bad will between organizations. It's kind of pockmarked the history of the competition. So the idea here was to present an open forum that multiple teams could join. We had people from 4 different independent organizations and 1 fraternity, from Apex, the Carnegie Involvement Association, Fringe, and Spirit, as well as Sigma Phi Epsilon, all contribute members to the project. And that was really the most successful part of it, just the fact that we had, this kind of a thing was unprecedented. We brought together people from 5 different teams, to all come together and sort of just discuss ideas. And we also hosted a series of educational seminars that were open to the entire buggy community to educate people who are freshmen, sophomores, people who don't have the background in basics of mechanical engineering, everything that goes into actually designing and constructing a buggy, the specifics of carbon fiber composite construction, and 3D computer modeling as well. The project itself focused on a couple different areas. We wanted to design new brake systems to potentially provide better performance on the course, because some buggies have demonstrated, even though they have passed Sweepstakes brakes tests, they actually have inefficient or uncontrolled stopping ability, which leads to hazardous braking performance on the course. So even though these passed the official brakes test, the goal was to develop and publicize sort of an open forum brake designs that would be more effective than these. We did do some designs for the brakes. The goal was to actually implement them, but that was the next step that we were going to go to after shell repairs. We didn't quite have the time to go all the way through with all of our goals, but we did have a lot of success repairing the shells. We started off with an old buggy that was rolled several years ago that had to be retired due to pretty much being a piece of junk. It was poorly designed, poorly executed, and in its final configuration after its last mechanical failure, declared unrollable and permanently banned from the sport by the safety chairman. So our goal was to take this buggy. It had multiple critical structural failures. The steering was broken and gone. There was delamination all throughout the shell, and just tear it apart, try and fix it, restore its structural integrity. And we fixed the delamination here. We replaced the frame and the floor, strengthened the front of the shell, did a whole lot of work here, made a lot of significant improvements to the quality of the buggy. And while it's still not something that could be considered safe to roll, it now passes the sort of can a person sit on it test that is used to determine the strength of the shell. And we did get a very strong proof of concept of this repair in the front, where we significantly reinforced the nose, because the nose is the most important part of crash protection, because it's all that's between the driver and hay bales or a curb. So before, the nose was very weak. It could have broken off by pulling on it, and now it's very strong. It's integral with the rest of the frame and the shell. So we reinforced that a lot, and we know what we would do to further strengthen and repair the shell. So I think the project ended up being a pretty good success for us.